Okay, so we're going to look at rational functions, and we're going to solve for the unknown, and the unknown is our x variable here. So like you said before, probably the fastest way to start this off would be to actually cross multiply everything. That way we've kind of gotten rid of any fractions we're dealing with. So we cross multiply with x and with the value of 2, which means whatever's on the top here, our numerator, we're going to be multiplying by 2, and whatever our numerator on the left is, we're going to be multiplying by x. So we're going to use distributive property. So essentially the x will multiply by both, and the 2 will multiply by both. And it doesn't tactically matter what side we put the multiplicative number on, because there's a rule in multiplication that it doesn't matter the order, you always end up with the same number. Okay, so when we do this, we get x squared plus x is equal to, and we'll have negative 12 plus 8x. All right. From here, scroll down a little. There you go. What we can do is it looks like, we'll try to collect all our like terms before we make any decisions what we're going to do. So I'm going to move our 8x, and I'm also going to move our...
Set it equal to 0?
Exactly. We're going to set it equal to 0. We're going to try to build a trinomial and then see if we can factor or use the quadratic formula to do that. That's good that you can see it from this point already. So when we move those two over, we're going to x squared plus x. When our 8 comes over, it's obviously negative, and when our 12 comes over, it will become positive. Perfect. And it's going to be set equal to 0. We'll just collect our like terms, so we now have a trinomial. And it's technically quadratic. You get that? Yeah. Okay, so I'm not sure which version of factoring they showed you. There's many, many different ones. Do you have a name?
I don't remember the name, but it's the one where it multiplies to AC and adds to B.
Okay. Okay. So then you would split the middle term. Is that what you guys do? Where you once you get okay. So that's called decomposition.
Decomposition.
Yeah, good. That's good that you know the title. Not much many students do. So
negative 6, negative 1.
Yeah, exactly.
Or negative 1, negative 6.
Good. Good. So we can have our negative 6x, negative 1. We're actually going to need two numbers that are multiplied to 12, and negative 6 so won't work. So let's actually write it on the side, just so we don't make an error with that. Our a value is obviously 1, and our c value is 12. So we need two numbers that multiply to 1 times 12, which is pretty straightforward. It's just two numbers that multiply to 12 in themselves. And our b value is negative 7. There you go. Very good. So negative 3, negative 4. So we're going to split this up. Negative 3x, negative 4x. And essentially the idea of splitting it up is if we were to put them back together, if we were to simplify, we'd end up with negative 7. So we haven't really changed anything in this equation. And then we obviously have our positive 12. We're going to common factor. We're going to look at the first two terms and common factor out of there. And then the second two terms. In the first one, we can pull x out. And when we do that, we'll be left with x minus 3. And in the second one, we can take out the value of 4. It's also technically a negative number, so we're going to take out negative 4 with it, so that their first term in the brackets, just like in this one, will also be positive. Okay? So when we take out our negative 4, we're left with positive x minus 3. Okay? Technically, what we do here is we common factor again, the common factor being x minus 3. Are you okay with that idea? Or do you want me to show you? Yeah? Okay. So we'll common factor that out.
Okay, I didn't know that was called common factoring.
Yeah.
I just moved those two together.
Yeah, and usually what happens is the teachers will tell you, okay, so they're the same, move it to the front, and whatever's left over is left over. I can quickly show you. If we were to do like a let statement, so I'll do it on the side. Say I said let a equal x minus 3. What this would read now is x times a minus 4 times a, and then we can common factor a out, and we're left with x minus 4, which is this bracket here.
I think when we were learning this method the first time, we did that.
Yeah, and then they just assume you know it from there. Yeah, exactly. And that's fine if you know it from there. And then we're going to find, because these essentially represent a term each, and they're going to multiply to 0, one of them must be 0. The only way you can get a 0 when multiplying is if you multiply by 0. So we're going to end up with two numbers, and we're going to set both of them equal to 0 to figure out what they are. Yeah, exactly. Very good. So that's good that you can see it right from there. So our x values, oops, I wrote that backwards. 0 equals x minus 4, so we get x is 4 and x is 3. Perfect. Good, you picked that up more than quick.